Welcome everyone to Innovate and Scale, the podcast where we bridge the gap between cutting-edge technology and business strategy. Today, we're diving deep into a fascinating challenge in the world of AI. How do we teach large language models what good looks like, especially for complex open-ended tasks?
It's a critical question, host. Businesses are deploying LLMs everywhere, but ensuring quality and alignment beyond simple benchmarks. That's the multi-million-dollar problem. It's like mass-producing a complex product. You need robust quality control, not just a final check, but throughout the process.
Exactly. We started with techniques like reinforcement learning from human feedback, or RLHF, which relies heavily on reward models, RMs, to guide the LLM. Think of the RM as the automated judge scoring the LLM's performance.
And how well do these traditional judges work?
They work but often rely on simple scalar scores, just a single number. It's like getting a grade without any comments. Useful but limited. Plus, pairwise models, which just compare two responses, lack flexibility. You can't easily score a single answer or scale up the judgment easily after the model is trained.
That's where Generative Reward Models, or GRMs, come in. Instead of just a number, a GRM actually writes feedback, a critique explaining why a response is good or bad. We're talking about moving from a silent judge holding up a scorecard to an articulate critic giving detailed notes.
So more like a performance review than just a pass-fail grade.
Precisely, and the paper we're discussing focuses on pointwise GRMs, which means they evaluate each response on its own merits, generating a critique and score for each one individually. This gives us much more flexibility. Score one response, score 10, it handles it.
But just having a GRM isn't enough. How do you ensure the critiques are good and consistent, especially across diverse, general tasks where there's no single right answer? That's the challenge the DeepSeek-AI paper tackles with SPCT, self-principled critique tuning.
SPCT sounds sophisticated. Break that down for us, Expert 4.
Think of it this way. SPCT teaches the GRM to first act like a philosopher, then a judge. It uses online reinforcement learning, learning on the fly, to train the GRM to first generate relevant principles or criteria for evaluation based on the specific query and context.
Like defining the rubric before grading the essay, that makes sense from a process perspective, standardizes the evaluation.
Exactly. First, define the rules, the principles. Then, based on those specific principles, generate the detailed critique and the score. It's a two-step generation process within the model itself. SPCT uses some clever RL techniques, including rejective fine-tuning as a starting point, to really hone this ability.
And this structure is key for the next big idea, inference-time scaling. Because the GRM generates text, principles, and critiques, there's natural variability if you ask it multiple times with a bit of randomness, like adjusting the temperature setting during generation.
So you can ask the same GRM to judge the same response multiple times and get slightly different, reasoned evaluations.
Yes, unlike a scalar model that likely spits out the same number every time. With a GRM trained via SPCT, you can run, say, 8 or 32 parallel evaluations of the same responses. Each run might generate slightly different principles or weigh them differently, leading to a unique critique and score.
It's harnessing the generative nature of the model itself for robustness, like asking several experts for their opinion instead of just one.
Then you aggregate these scores. The paper suggests simple voting, essentially summing the pointwise scores from all the parallel runs. This often leads to a much more accurate and nuanced final judgment than a single run. It's leveraging compute at inference time to boost quality.
So more thinking time, or rather more parallel thinking time, equals better judgment.
Pretty much, and they take it a step further with a meta-RM. This is another model trained specifically to predict how good or reliable each individual critique generated by the main GRM is.
A judge for the judge's reasoning.
Chuckles, you could say that. It helps filter out potentially low quality or biased critiques before the final voting aggregation. So instead of simple voting across all 32 samples, you might only vote using the top 16 samples identified by the Meta RM.
Okay, let's translate this to business value. What does this improved judgment capability mean? The paper shows DeepSeek-GRM outperforming strong models, sometimes even larger ones, just by using this inference-time scaling. That sounds like potential compute efficiency. If I can get better quality alignment or evaluation from a moderately sized model using more inference compute, that might be cheaper or faster than training a massive model. It shifts the cost profile. As Peter Drucker said, efficiency is doing things right, effectiveness is doing the right things. This seems to aim for both more effective judgment, potentially achieved efficiently.
Hold on a second. While the results are impressive, let's not get carried away. This inference-time scaling isn't free. Running the RM 8, 16, or 32 times multiplies the inference cost for the reward modeling part significantly. Is that always practical in production?
That's a fair point, Expert 6. The efficiency of GRMs is inherently lower than scalar RMs due to the text generation. Scaling that multiplies the cost. However, the paper argues the performance gains can outweigh the cost, especially compared to the cost of training much larger models.
Perhaps, but I wonder if we're overlooking something. The paper notes these GRMs, even DeepSeek-GRM, still lag behind specialized scalar models on purely verifiable tasks like math or code correctness checks, although they can be improved with reference answers.
That's true, the generalist nature might dilute focus on strict verification unless guided. It's a trade-off. A polymath might not outperform a specialist in their specific domain, but offers broader capability.
My surprise point, or maybe a contrarian thought, is this. Is the real magic here the SPCT method itself, teaching the model to generate principles and reason better? Maybe the inference scaling is just amplifying an already better model, and the gains might plateau or have diminishing returns versus simply improving the base GRM further or using hybrid approaches.
That's an interesting angle, Expert 6. Building on what Expert 4 said about SPCT, it fundamentally improves the GRM's reasoning process. Inference scaling definitely leverages that improved capability. I agree there might be a balance. Perhaps future work involves smarter scaling, maybe dynamically deciding how many samples are needed based on task ambiguity.
I think SPCT and inference scaling are synergistic. SPCT creates the potential, the ability to generate diverse, principled critiques. Scaling unlocks that potential by exploring the space of possible evaluations. You need both for these results. The Meta RM, as Expert 5 described, is crucial for making the scaling effective by weeding out the weaker evaluations.
It sounds like a powerful combination. Expert 1, where do you see immediate applications for businesses ready to leverage this kind of nuanced AI evaluation?
Oh, the potential is huge. Think about automatically evaluating customer service chatbot interactions for helpfulness and empathy based on defined principles, or providing richer, actionable feedback on AI-generated marketing copy beyond simple A/B testing metrics. Internal uses are key too, refining internal knowledge base assistance, providing developers with more insightful feedback from automated code reviews generated by an LLM, even monitoring content generation platforms for adherence to complex safety and quality guidelines. The 80-20 rule might apply. 80% of the value comes from evaluating those complex, nuanced tasks where simple scores fail.
We even had a light moment earlier about the Meta RM being like a manager reviewing reviews. Expert 3, you had a good comeback.
Yes, hopefully the Meta RM is less prone to office politics and more data-driven than some review processes I've seen. It's really about optimizing the aggregation of signals.
Laughs, let's hope so. So looking ahead, what's next for this field? Expert 5, maybe start us off.
I think refining the Meta RM concept is key, making it even more efficient and accurate in guiding the voting. Also, exploring the interplay between the number of samples, the Meta RM's filtering, and the overall cost-performance curve.
Extending SPCT itself. Can we make the principal generation even more adaptive or incorporate external knowledge sources or tools directly into the critique process? Imagine a GRM using a calculator to check math or a search engine to verify facts within its critique.
I'm excited about using these GRMs not just for post hoc evaluation, but potentially during RL training loops. If they become efficient enough, they could provide much richer training signals than scalar RMs, leading to more capable policy models.
And the idea of using them as offline evaluators is powerful. Since SPCT makes the GRM generate its principles, you could analyze why one LLM is judged better than another on a dataset by looking at the common principles cited in the critiques. That's interpretable evaluation.
My focus would be on tackling the efficiency head-on. Can we distill the multi-sample knowledge back into the base GRM? Or develop architectures specifically designed for efficient, parallel critique generation? And we still need better benchmarks that truly test generalist reward modeling across even more diverse, real-world scenarios.
From a business perspective, the next step is standardization and ease of implementation. How can we make it simple for companies to fine-tune and deploy these advanced GRMs plus meta RMs for their specific quality criteria without needing a team of RL PhDs? That's crucial for broad adoption.
Fantastic insights. It seems we've moved from simple AI judges to sophisticated critics capable of defining their own standards and benefiting from collective wisdom through inference-time scaling. The SPCT approach and the DeepSeek-GRM model certainly give us a glimpse into a future of more nuanced, reliable, and scalable AI evaluation. That's all the time we have for today on Innovate and Scale. A huge thank you to our panel of experts for unpacking this complex topic with such clarity and depth. Join us next time as we continue to explore the frontiers of technology and business. This paper presents a new learning method for reward models. The method improves how reward models scale using more computation during inference. It uses pointwise generative reward modeling. Generative reward models produce textual critiques as rewards, not just scores. Pointwise models assign individual scores to each response. The new learning method trains models to generate guiding principles first. Then, models generate critiques based on these principles. This learning process uses online reinforcement learning. The approach scales performance by generating multiple critiques in parallel. A voting process aggregates these critiques for a final reward. A meta-reward model guides voting for even better scaling. This approach significantly improves reward quality and scalability. Resulting DeepSeek models outperformed other methods on benchmarks. They showed fewer biases across different domains than other models. Inference-time scaling proved more effective than increasing model size alone. Generative models are currently less computationally efficient than scalar models. Performance still lags in some specialized areas like verifiable tasks. Future work could improve efficiency and integrate these models more broadly.